All right, so the topic for this video is going to be Cpctc. What we're going to be looking at here is how can we use congruent triangles to prove other properties or other theorems. All right, so last we left off on the last video was using Euclid's methods of proving triangles congruent. Now this says, with the knowledge of what congruency means, Euclid set out to use congruent triangles to prove other theorems and properties. And the way that he did that was by using Cpctc, which stands for corresponding parts of congruent triangles are congruent. Cpctc. And what that means is that if two triangles are proven to be congruent, then all other corresponding parts also must be congruent. All right, so for example, let's look at this one. To determine why the triangles are congruent and list the other congruent corresponding parts. Well, by doing what we've been doing, we would know that the vertical angles are congruent, which means that we've got side, angle, side, right? So we could say triangle ABC is congruent to triangle, I would have to do not E, A matches D on this one. So DCE, and we'd say by side, angle, side. Right, so those two triangles we could prove to be congruent by side, angle, side. Now what that means is that once those triangles are congruent, once we have proven that they are congruent, that means all the other corresponding parts are also going to be congruent. So anything that is not marked in this diagram, we could then say must be congruent. For example, now angle A must be congruent to angle D, right? Those are matching parts. Likewise, angle B must be congruent to angle E, since those are corresponding parts. And then, lastly, the only other thing that isn't marked is side AB and side DE. So what we are saying now is once we establish that two triangles are congruent by using side, angle, side, or HL, then all the other parts that aren't congruent yet must be congruent. Because if two triangles are congruent, then all their things are congruent, not just the ones that we already knew. So what we're going to be doing, we're going to be proving some triangles congruent and then using those to prove other things congruent. So it's going to be very similar to what we did in the last video. I'm just going to extend it a little bit. So let's get started on this one. So what do we know? We know angle A is congruent to angle C, and angle ABD is congruent to angle CBD. Both of those are given to us. So that is already two congruent things that we have between these triangles. A with C, ABD with CBD. So really we need one more congruent thing, then we can say our triangles are congruent. Well, luckily for us, we got the reflexive property in there. BD is congruent to BD by our old friend, the reflexive property. Now that we have our three congruent things, now we can go ahead and say that triangle ABD is congruent to triangle, let me line this up, I did ABD, this has to be CBD by angle, angle, side. Okay, so here's where we left off in the last video. Last video we were just proving triangles congruent. This would have been the final step if we were doing one of those. But look at what we're trying to prove. We're trying to prove that side AD is congruent to side CD. And that's not marked right now. But this is the power of Cpctc. Now that we know those triangles are congruent, we can say anything else that isn't marked must be congruent by using Cpctc. Corresponding parts of congruent triangles are congruent. Anything that isn't marked is now officially congruent by using Cpctc. And that's it. So really all we're doing here, proving those triangles congruent and then going a little bit further using Cpctc. Let's try another one on the inside. All right, so example 3, what do we got here? We've got AB parallel to DC and BC parallel to DA. Ooh, this is going to be a big one. The reason I know it's going to be a big one, other than the fact that we got a lot of blanks here, is that we don't have any congruent things right now. All we've got are some parallel lines. AB and DC are parallel, and then BC and DA are parallel. Okay, so let's start getting some congruent things. One thing right away, they share that side in the middle. BD congruent to BD, reflexive property. Now let's start using those parallel lines. Let's start off by looking at AB parallel to DC. If those lines are being crossed by this transversal here, that means that angle ABD, angle ABD must be congruent to angle CDB, because those are alternate interior angles. So I'm going to use the alternate interior theorem. Then likewise, if AD is being crossed and is parallel to BC, so looking at the purple lines with the blue transversal, I've got these two angles being congruent. So angle ADB congruent to angle CBD using the alternate interior theorem. Okay. So what now? I have officially gathered my 1, 2, 3 congruent things. What I have is an angle, a side, and an angle. So now I can say triangle ABD is congruent to triangle. If I did ABD, I got to do CDB by angle, side, angle. And now that those triangles are officially congruent, AD must be congruent to CB by Cpctc. Since those triangles are congruent, all their corresponding parts are also going to be congruent. Anything that wasn't marked gets to be marked now. And just as a reminder, anytime you see parallel lines in the given, you should be thinking about alternate interior angles. It's a huge hint. All right, what do we got here? We got MK is a median, and JM is congruent to LM. Okay. What do we need to do here? Well, okay. So JM, LM. We got one congruent thing. Oh, and yours has one more step there because it needs one more step. Let's get KM congruent to KM by the reflexive property. All right, anytime those triangles are smushed together, we get to mark that side in the middle. That's a second congruent thing. We need a third congruent thing. Well, luckily, we know what a median does, right? The median splits an opposite side in half. So JK is congruent to KL because definition of median. That gives us our three congruent things. So now I can say triangle JKM is congruent to triangle. If I did JKM, I got to do LKM. Because definition, oh no, not definition. I've gone insane. It's because we have a side, and a side. Okay, and now that we've got side, now that those triangles are officially congruent, now we can say angle JMK is congruent to angle LMK because of Cpctc. Silly me, I didn't do my normal highlighting. All right, so same strategy, right? Get your three congruent things, get your triangles congruent, and then you can accomplish the other thing by proving the angles to be congruent. Okay, so what do we got here? Ooh, okay. So this one is a little bit beyond even what we were doing. We'll take it one step at a time. So what do we have as the given? We got AD congruent to CB and AB congruent to CD. So AD, CB, AB, CD. Okay. Now, the good news is that we already have two congruent things in our given, right? So if we're just focusing on trying to get these triangles congruent, first of all, and not even really worrying about what we're trying to prove, that means we only need one other congruent thing, right? And it should be pretty clear. We got DB in the middle. So that's the reflexive property. And now that we've got our three congruent things, that means we can say that the triangles are congruent. So triangle ADB congruent to triangle. If I do ADB, I got to do CBD. And this is because a side, and a side. Okay, so we've proven the triangles to be congruent. Pretty easy. Now let's look at what we're trying to actually prove. They're asking us to show that this line AD is parallel to BC. And if we're trying to show that two lines are parallel, we got to think back a little bit. In a previous video, we did do some proofs where we were proving why lines were parallel. And the way that we did that was by using converses. If we can show that a certain set of special angle pairs, a special angle pair formed by these parallel lines are congruent, then we can use one of the converses to say that the lines must be parallel. So what I'm thinking about is look at this transversal here. If, for example, these two angles were congruent, that would mean that those lines must be parallel. And luckily for us, we can say those angles are congruent. We can say that angle ADB is congruent to angle CBD because of Cpctc. Those are corresponding parts of these two congruent triangles. And now that we officially have those alternate interior angles being congruent, we can say that AD must be parallel to BC by the alternate interior converse. That was tricky. That was pulling in a theorem that we haven't seen in a little bit in a few videos. But we use Cpctc to get those angles to be congruent, and then we use those angles to say that those lines must actually officially be parallel now. Pretty cool. Okay. So we got one more where we got to use Cpctc to get something accomplished here. This one says Km is an altitude and Jk is congruent to Lk. Okay. So looks like we're starting off with one congruent thing, just JK and LK. Let's go ahead and get the reflexive property in there. Km is congruent to Km. Reflexive property. That's our second congruent thing. And then let's think about what an altitude does, right? What does an altitude do? An altitude goes from a vertex and makes some right angles, right? That's what it does. So let's go ahead and talk about those right angles. Angle JMK and angle LMK are right angles. Because definition of altitude. And that's going to count as our third congruent thing because those right angles have to be congruent. And that's going to actually show us that we've got a leg and a hypotenuse. So I can say triangle JKM must be congruent to triangle LKM by HL. Okay, so that's what we were doing in the last video. But now what are we trying to prove? We're trying to prove that Km is a median. So in order to show that Km is a median, we got to show that it's doing a median's job. And what is a median's job? A median's job is to split the opposite side in half. So can we officially say that JM is congruent to LM? Because that would show that that side got split in half. And yeah, we can. LM has to be congruent to JM. Why? Because Cpctc. We just showed that those triangles are congruent, which means that all of their corresponding parts, even the parts that aren't marked, can be marked. So JM is congruent to LM because Cpctc, and that shows us that Km is a median because it does a median's job. It split that opposite side in half. Definition of median. And voila, we have proven what it is that we were trying to prove. Okay, so your turn. You've got 2 to try. Give those a shot, and then come back and see how you did. All right, so hopefully those went well. Let's see here. Km is an angle bisector, and JK is congruent to LK. Okay, so we've got one congruent thing. We need 2 more, one of which is that Km is congruent to Km, reflexive. The other would be that angle bisector splitting that top angle to 2 equal pieces. So angle JKM is congruent to angle LKM by definition of bisector. That gives us our 3 congruent things, which is going to let me say that triangle JKM is congruent to triangle LKM by... I haven't been marking my diagram, I'm sorry. That'd be by side angle side. And then we can officially say that JM is congruent to LM by Cpctc. Not too bad. And then this last one, we've got AC congruent to EC and BC congruent to DC. Both of those are given. We need a third congruent thing, and that's going to be the vertical angles on this one. Angle ACB congruent to angle ECD. Vertical angles theorem. That's our three congruent things. So I can say triangle ACB congruent to triangle ECD by side angle side. And if we're trying to prove that these two lines are parallel, we need an angle pair that uses those. So one angle pair that I see is angle B and angle D. So let's go ahead and grab those using Cpctc. Angle A congruent to angle D, Cpctc. And then those are alternate interior angles with those lines that we want to be parallel. And the alternate interior converse says that if the alternate interior angles are congruent, then the lines are parallel. So we're going to wrap this up with a little alternate interior converse. Okay, hopefully that went well, but that's going to wrap up our video here.